Alright guys, welcome to lesson 1.3. I'm wearing pink because I actually recorded this video on a Wednesday, and as you know, on Wednesdays, you have to wear pink. Mean Girls reference, and if you didn't watch my first video, maybe you don't know where this is coming from. I do want to say thank you if you are watching these videos, because it means you're doing what I'm asking you to do. You are going to be getting an extra benefit of really practicing these warm-up questions, which I told y'all again, I'm not wasting your time with these. These are things that if I were to go to a quiz, fast forward to next week, what are kids gonna miss? These types of questions. So I'm always pulling up things that are like, okay, we learned them yesterday, you did them on your homework, but do them again. Like, make sure these things are in your head. These are commonly missed things and things I want you to practice. So I'm gonna kind of step aside. It does say that the ordered pairs are -2, -3, and 1, 3. And I'm asking you to do 3 totally different things. I want you to find the equation that contains those points. So that means finding the slope and calculating the y-intercept, and then find AB. Notice no notation at the top means give me the distance. And when these are 2 ordered pairs in space that aren't on a number line that I can just count sideways, even if you graph these, you are not allowed to count diagonal and be like, looks like 6. Like, that doesn't work. If you do choose to graph it, you're gonna count the right triangle. So like if the 2 points are in space, you're going to connect them into a right triangle. You can count the horizontal and vertical perfectly, and then you can do your a squared, b squared, c squared. Okay, and lastly, just to practice something that was on the notes yesterday, finding a point that's 1/3 of the way between those 2 points. So I'm going to kind of put my hand up for 5 seconds. If you want to pause this video and work those out, do that. Otherwise, here we go. Okay, I'm going to quickly write down just the answers, and if you have this perfectly correct, like there's not even the tiniest thing that you got wrong, then I give you permission to fast forward through this video and skip until we get to the notes, okay? If you got just one of these wrong, fast forward a little bit and see when I start to talk about that one, and if you missed all of these, or didn't do it because you don't know how to do them, then you definitely want to listen through all 3 of these, okay? But do what makes sense to you. All right, so the first thing, we have these 2 ordered pairs, and for the purpose of this, I am going to go ahead and graph them just so you can see what's going on, although you really can answer all of these questions without ever graphing them. So -2, -3, so -2, -3. Again, you'll notice I'm kind of using graph paper because this is how I like to use a graph paper notebook, so that you have the option to plot points like right here while you're taking notes without having to draw a graph each time. So find the equation. Well, I want to know what the slope is. So if I was going to count the up and over, this is up 1, 2, 3, 4, 5, 6. So up 6 and over 1, 2, 3. So up 6 over 3 gives me a slope of 2. So I know that this equation is y equals 2x something. And if I do know that it's a reduced slope of up 2 over 1, I can now recount these points. Up 2 over 1, up 2 over 1, up 2 over 1. You'll see that I'm getting those same points. You'll notice this one does beautifully cross the y-intercept at +1, so you're welcome to just fill that in. However, I did say, well, can't you do this without graphing it? And so what you would do instead is you would say, okay, think about rise over run. For rise over run, I want to focus on the y value first. How far up did it go? Again, here's my 0. So from a -3 up to a +3, we really did go up 6. And then from a -2 to a 1, we did go up 3. And when we're talking about distance, I might not care about that being positive or negative, but when I am talking about slope, it is going to matter whether I added or subtracted in that order, because that is going to affect what way this slope had been. So this is where I would get that 2 from. And if I didn't have the graph to look at, this is where you basically borrow a point to solve for b. And because I'm allowed to pick any one I want, I pick, to me, the prettier looking one. Y equals 3. 2 times the x value is 1, and I don't know plus b. Unlike a lot of our homeworks, this is pretty easy to do because there's no fractions. 2 times 1 is 2, subtract the 2 over, and 3 minus 2 is 1. So I'm able to find out that that y-intercept is 1 without graphing it to see where it's at, right? So I'm just kind of giving you some different things to look at. It says find AB. Find AB with no bar on the top means that I want to know the distance between these 2 points. And you cannot, I cannot tell you how many people will be like, looks like 1, 2, 3, 4, 5. Like, you cannot do that. You will get the answer wrong every time. I'm going to look at your paper, laugh at you, and put X. So don't do that. If I said, what's the distance between this point and this point, and they're on a straight line, well, heck yeah, 1, 2, 3, 4, done. Okay, you can do that. But when they are in space, you cannot do that. So you kind of need to look at a right triangle. It could be this right triangle, or it could be this right triangle. Both of them are going to give you the same information, but what I need to know is what is the base and height of that triangle. It's also the same numbers you counted for slope. So if I have the graph, I can see that it's 6 faces and 3 spaces. So my Pythagorean theorem, one of them is a 6 and one of them is a 3, and that'll help me find my hypotenuse, which will be the distance. Alternatively, you up here asked how far away are these? From a -2 to a 1, it's a distance of 3. From a -3 to a 3, it's a distance of 6. And those 2 values are the same ones here, again, that I could find without the graph. Well, now it's solving this. A squared, so 3 squared is 9, plus 6 squared is 36, is equal to x squared. 36 plus 9 is 45. And then I square root. Because 45 does not have a beautiful square root, we leave it as square root of 45. For this point of our class, we will let you leave the answer that way. But we did mention if you know how to break it down, go ahead and start practicing that, because eventually you will have to leave your answer that way for full credit. So 45 breaks down into a 9 times 5, 9 keeps breaking down to 3 times 3, and now I'm at all of my baby pieces. I'm looking for pairs, the pair comes outside. Okay, and if you don't know how to do that, you're a little confused by it, you can wait till we eventually teach you this, or feel free to jump on a Zoom call and ask, and I can walk you through those things, no problem. But again, if you were to leave the square root of 45 right now, that's okay by me, while we are waiting to get to that point. All right, so the last one is asking me to find a point that is 1/3 of the distance from those points. So, and this is going to kind of come up a bit today also. So if I'm saying that I'm at -2, -3, eventually I got to 1, 3, I'm looking for some point that's in between. Now it's not dead center in the middle, because we're only going 1/3 of the distance. So I'm going to have to ask myself, and you'll notice it's going to use those same 2 numbers that we've been using for all of this problem. From a -2 all the way to a 1, I added 3 to get that far. Well, this new point that they want is only 1/3 of the distance. So what is 1/3 of 3? Okay, if I cut that in thirds, I'm only going to actually add 1 point. So -2 plus 1 is -1. Similarly, from here, from y value to y value, it added 6. So from a -3 to a 3, we plus 6, but I only want to go 1/3 of that distance. So dividing that into thirds means I'm only going to go plus 2. So -3 plus 2 happens to also be -1 just by coincidence. And so on our graph, I'm going to highlight for you the original 2 points where this -2, -3, this 1, +3, and they said, what is 1/3 of the way? 1/3 of the way we said was -1, -1. That's this point right here. So essentially what we're getting at is if this is the full distance, like this would be like the halfway point, if I were to cut this into thirds, 1/3 of the way is this point. So sometimes, depending on how friendly the numbers are, you might be able to graph it and kind of, observe where that's at, but this is the general steps that will always work if we're using numbers too big for a question. The one thing I will give you for some peace of mind is that we will not give you something that doesn't divide in half or in thirds or in fourths perfectly. We will only ask you to do a problem where the full amount is going to be divisible by the amount it's asking. So that I will tell you is one thing that we're going to do. Okay, So that was the warm-up, but again, those are all things you must know for your quiz. So if you want to rework through those again and like watch this again, like you've got to do that. Go on YouTube if you want to see some different people explaining it. Go on Google for more examples. Whatever you want to do, you're a pre-AP student. I trust your ability to do research. All right, so now let's get into the lesson of today. What is the value of x and AB if B is between A and C? So I think this is just some extra practice from yesterday to kind of keep it going. So AB if B is between A and C. So we've got some magic point A, some magic point C, and B is somewhere between them. And like I mentioned in yesterday's video, I don't like to put it dead center unless it's supposed to be. Now I don't know if it's closer to one or the other, but it doesn't matter because the scale of this isn't going to be anything. I just don't like putting it in the middle because then I feel like it's supposed to be. All right, what is the value of x and AB? B is between blah, blah, blah. So AB is 3x plus 2, so this distance here. From B to C is 7, and from A to C, the entire distance is 8x minus 1. So the equation that we're going to put together is that the 3x plus 2 part plus the 7 part is equal to the whole thing, 8x minus 1. And then just work through my algebra. I need to gather my like terms, so I tend to keep my x positive. So for me, I'm going to subtract my 3x over here. I'm going to add this one over here, and in total, this is 7, 8, 9, 10 is equal to 8x minus 3x, 5x, divide both sides by 5, and get x value of 2. Okay, if you're somebody that prefers to do a step-by-step algebra problem, that is your choice. We are a pre-AP course, which means slowly I'm going to push students who are able to do it to kind of just collect and move things quicker. But again, those are things you're always welcome to come on to Zoom calls to get some more feedback on. Now, it did ask what is x, so I am excited to label that, but it also is asking me the distance from A to B. And if this was a quiz question, I would need to know which one it wanted if it only asked for one. The distance from A to B is 3x plus 2, and now that we know x was 2, 3 times 2 is 6, 7, 8. So the distance AB, or the length of AB, is 8. Okay, this one, we've got a little symbol here. This symbol means congruent. It means that those two segments are going to be the exact size and shape of each other. So one of those segments is 4x minus 2. The other segment is equal to 3x plus 3. And because they are the same size and shape as each other, that means that I am allowed to set them equal and solve. Okay, minusing 3x is 1x, plusing 2 is 5. Notice here it does not ask me what x is, so I'm not going to worry about it. So it says, what is the length of that segment? Now again, they could have just said, what is AB? And that would have been the same thing. But here they use the vocab word, the length of segment AB, but they could have just said, what is AB with no notation? It's the same thing that we would be looking for. If x is 5, 4 times 5 is 20, minus 2 is 18. Okay, so most of that's just a refresh from yesterday, just to continue to see more problems. 1.3 midpoint and distance. Midpoint is the point that basically is exactly in the middle. So not like kind of is somewhere in between, it is the middle point. There is something that's called a segment bisector. That's a fancy word that just says I can take some segment, and if there is such a thing called the midpoint, it might be there because a line cuts through this, or another segment cuts through this, or a plane, or any. So they'll sometimes refer to the object as a segment bisector, means that it cut it in half, and the location of that point is referred to as a midpoint. But just if you see the word segment bisector, it's more like the object that did cut it in half. So this red line is the segment bisector of the green segment, right? So that's the segment. This bisected it, so therefore I know that these two sides are congruent in value. All right, midpoint formula, just like distance formula, I don't believe in this. I hate that formula. That formula is fantastic for here's an endpoint, give me the middle. But what this does not work for is I know what endpoint, I know the middle, where's the other one? That formula, scrap it, can't use it. What if I said, I don't want the midpoint, I want half, well not half, I want a fourth of the distance or a third of the distance. That formula, useless, right? So I don't like useless formulas, I like making sure you know how to do things. And if you kind of understood yesterday's lesson about counting the distance to the points, same things we saw in the warm-up, we're gonna basically do that here. All I need you to do when we look at these 4 questions real quick, and then I think we're done for the day, is understand, am I looking for the midpoint or do I have the midpoint? Because in a question involving midpoint, I'm going to know 2 of these things and I'm going to want to find out the other. So in this case, what do I know? I know that the endpoint is negative 2, 5. The other endpoint is 4, 1. And so I'm already pre-planning that the answer they're looking for is the point in the middle. All right, well, let's do midpoint the way I want you to do midpoint. From a negative 2 all the way to a 4, how much did they add or subtract? From a negative 2 to a 4, they went plus 6. Okay, well, a midpoint, kind of like our example up there in the warm-up where I divided by 3, midpoint is always cut that in half. So I'm only going to add 3, half as much to get there. So negative 2 plus 3 is 1. And you should observe that if I do negative 2 plus 3 is 1, and if I go plus 3 again, it's 4, because it's the exact stepping stone of a point that's in the middle. For the y values, if I go from a 5 down to a 1, I subtracted 4. But again, midpoint, so I'm going to divide that by 2, and I only want to do half of that. So I'm going to only subtract 2. So 5 minus 2 is 3. And again, if you minus 2 again, you would land at 1 and be like, that's right, it is working, I did it. So what's the midpoint? It's 1, 3. Okay, again, there's a formula that works great for like add these up, divide by 2, add these up, divide by 2, and you're gonna be like, why don't I just do that? And then as soon as we get to like any of the other questions, you're gonna realize there's a reason I don't like the formula. It is only good for this question and nothing else. Okay, I'm gonna do the second one a little bit faster because it's the same concept. They're asking, find the midpoint. So again, setting this up, I know that one endpoint is 8, negative 6, the other is negative 14, 12, and we are looking for this middle point. From an 8 all the way down to a 14. So I had to subtract 8 to get to 0 and subtract 14 more to get to negative 14. So 14, 15, 16, 17, 18, 19, 20. Okay, so to confirm, I'd subtract 22. So to get here, I want to cut that in half and only subtract 11. 8 minus 11, negative 3. Check yourself. If I subtract the other 11, yes, like so that does feel like it's landing in the middle. Y value, from negative 6 all the way up to positive 12, I'd add 6 and add 12. That's a total of adding 18. Again, I only want to go half of that for the midpoint, so we're going to add 9. Negative 6 plus 9, positive 3. Check yourself. Add the 9. Yes, it does get me to 12, so that perfectly is a half and half stepping stone where that is the midpoint. Okay. This problem, it says find the coordinates of letter choice D if this is the midpoint and the other side F is here. So at this point, I know one of the endpoints and I know the midpoint. And I probably should have brought this up in these other questions. It actually wouldn't mathematically matter if you switched these 2 points. You might read it in the other direction, but you're going to still land at the same point in the middle. In fact, if you want to try it on one of them just to see and prove it to yourself that that does that, you could do that. But why I do this is if I know the midpoint, I always like to put the other point that I know first, just so that I'm always working towards the right, just because I like it to feel sort of the same. But you'll notice I'm in a big box on this point to remind myself that what I'm looking for is over here. I know the midpoint. So this time, we're going to say from negative 5 to negative 6, to get halfway there, I did minus 1. Well, I need to do that minus 1 again, right? Like, so if I went minus 1 to get halfway there, minus 1 one more time to get the rest of the way there. Same thing with the y value. From a negative 3 all the way to a 4, I added 7. So I need to add 7 more and get to 11. Okay? So that is, again, the structure is, do I know the midpoint? Then I need to know how far did I go and do that again to get to the other side. Or did I know the whole thing? How far is that? Now only walk half of that distance, right? Again, those are the main differences in those two questions. Okay, last example that's like that. So they're telling me this is the midpoint. So my structure is, I know the midpoint is 8, negative 3. I know one of the points is here. And my goal and why I box this now is to remind myself which point I'm looking for. Negative 1 to 8 is plus 9. Adding 9 again, 17. 5 to negative 3, subtract 8. And negative 3, subtract another 8 is negative 11. Okay, and I know I'm going a little fast because you have the opportunity to pause this video or whatever you need to do to go back and look at it. But again, looking at those different structures. Last question, and then I'm going to be done for the day. This one says, what is the measure of AC if B is the midpoint? So they're telling me B is the exact midpoint, which means that this distance here is the same as this distance over here. And they've labeled two things for me. They've told me how far this is, it's 2a minus 1. And they've told me how far the whole thing is, 3a plus 1. And I need an equation that's going to help me solve that. And here, I'm not just going to like set them equal and hope for the best. Like, that's not how we geometry. We go, well, if this side is a 2a minus 1, and this side is the exact same thing, then I know what both of the parts are that add up to the whole distance. So 2a minus 1 plus another exact perfect copy. And why is it an exact perfect copy? Because this is a midpoint. And if that's the case, then I know that equals to the whole thing, 3a plus 1. Gather my values. So I have 2 plus 2 is 4. Subtract 3 is 1a. Here, negative 1 and a negative 1 combines to negative 2. Move to the other side, plus 2, gives me a is 3. Now, it's asking me for how long is AC. So they're not asking me that a is 3. They want to know what is the whole distance all the way across, and sort of plug that in. 3 times 3 is 9, plus 1 is 10. So the distance AC is 10. Whew. All right, so hopefully that all recorded on that last step. My phone did a little blip, so I'm hoping that worked okay. Here is the homework that goes with this. Again, you can always find this on your calendar as well. And again, I know the video ran a little long, but the goal is if you understood the warm-up, you should have been able to fast forward through the warm-up explanation and just move right on to the notes. Again, the textbook, here are the pages, here's the stuff, some reminders. I think I accidentally kept writing Friday on the last two videos. Sorry guys, I caught that. The date was right. But again, you have a quiz coming up next week, whether you're in person or on KVA, and then your chapter worksheet will be due the day before the test. All right, have a good one.